All right, here we go. It is radicals enlightenment time. I know many of you may have fear over multiplying square roots together, dividing square roots. So hopefully this quick tutorial video will help you for today, but will help you with all of the other sections where we might be required to do this. So for A, take a look. Square root of 5 times square root of 5. What I'm going to do is just multiply those two together. That gives me 25. And now the square root of 25 ends up being a perfect square. Hopefully you remember that from last week around this time, that anytime you take a square root and you multiply it by itself, you get that number not in the square root anymore. Now, what happens if I have a 4 roots of 5 times 3? Only numbers outside the square root will multiply and affect other numbers that are integer whole numbers. So this 4 and this 3 will multiply to give me 12, and the square root of 5 just comes along for the ride. Same thing here in C, square root of 2 times square root of 5. The only thing that will change a square root is multiplying it by another square root. Therefore, we get square root of 10. That is a simplified radical right there. I can't go any further. Final answer, square root of 10. Now for D, square root of 6 times square root of 8 is going to give me square root of 48. Now this number is a little bit bigger, and so I'm going to explore, is there a perfect square that goes into there? And it turns out that the square root of 16 goes in there 3 times. Square root of 16 is 4. 4 roots of 3. Final answer. So that's how you multiply radicals. Whole numbers multiply with whole numbers. Square roots multiply with square roots. They stay under the square root symbol and then look to simplify if possible. Now dividing. A is probably best case scenario. 2 roots of 3 divided by square root of 3. If I have a square root in the numerator that is the same number as what is in the denominator, they will cancel. Final answer, 2. If I have a number in the denominator that's a square root, but I do not have a square root of 3 in the numerator to get rid of it, this is what I'm going to have to do. I cannot leave that square root on the denominator. So what I'm going to do is multiply the top and the bottom both by square root of 3. Now the reason I do square root of 3 over square root of 3 is that's the equivalent of multiplying it by 1. It's like we're unsimplifying it. Square root of 3 times square root of 3 is 3, not in a square root. 6 times square root of 3 gives you 6 roots of 3. And so now at this point, the only thing that can change, that can go with one another, is this 3 right here can evenly divide into this 6 because neither one is in a square root. Therefore, final answer, 2 roots of 3. Let's take a look at C. 14 divided by the square root of 3. We are going to multiply, again, by square root of 3 over square root of 3, because a whole number will not divide with the square root. So I don't want to put like square root of 4.66 or anything like that. The reason I choose square root of 3 over square root of 3 is so that when I multiply the denominator, I get 3. In the numerator, I have a whole number and the square root, so I just put those together. Since 3 does not divide into 14 evenly, final answer, 14 roots of 3. So what I'm hoping you can do is watch those examples, retry those examples, and then take a look at these other 2 slides called What Did You Learn? And I want you to use these 8 problems, some of which are a little bit easier, some of which might be a little bit challenging. I want you to try those and then check the follow-up video to see how those are solved, to really see, do you have a higher comfort level with regards to multiplying square roots by square roots, and what might prove to be the more challenging piece, dividing, like we've got in E and F when you're dividing by a square root. So check out that follow-up to these 8 problems on What Did You Learn?